In this question, what we have to do is use these special identities known as sum of angle identities, and they are sine A plus B. It might be tempting to write it as sine A plus sine B, like algebra. But remember, sine of A plus B is 1 theta, one angle. This is sine theta, where theta happens to be A plus B. So this is identical to sine A cos B plus cos A sine B. That's it. If this was minus, this would be minus. So sine of sum of the angles A plus B is sine cos, cos sine. The other one is cos. Cos A plus B is identical to cos cos, cos A cos B minus, remember this is plus, so this is going to be minus, sine sine, sine A sine B. So that's the idea behind the sum of the angles. If this was minus, on the other hand, then this would be plus. So this is the idea. So let's take a look over here. Now the first one is sine 15. So this is A. So that makes it sine 15 cos 20. Sine cos, cos sine, sine cos, cos sine. One is A, the other is B. So that means sine A plus B. So the first one is going to be sine A plus B, which is sine 35. The next one, question number B, we have sine cos minus this time cos sine. So it is going to be sine A, which is 58, minus B, which is 23. So this is going to be sine 35. Then the next one, question number C, is cos cos sine sine. Remember, if there is a minus, it is going to be sum of the angles plus. So cos cos. So this is going to be cos A plus B. That makes it cos 210 degree 130 plus 80 is 210. Question number D. Tan. This is tan. Now tan is something which is a bit different. So let me do the tan question at the end. So we have two tan questions over here. We'll do this later on. So question number E is cos cos sine sine. So 2 theta is A, theta is B. So this would be cos A minus B. Remember, there is a plus over here. So if there is a plus, it's going to be minus. If there is a minus, it's going to be plus. So remember the reverse thing over here. So it would be A minus B. So 2 theta minus theta, it would be cos theta. Now, the next one is F. So we have cos cos, again minus sine sine. So since there is a minus here, it would be sum cos A plus B. A is 4 theta and B is 3 theta. So this would be cos 7 theta. Now the next one is G. G is sine cos cos sine, and there is a plus, so the angle also is going to be plus. So this would be sine A plus B. Now A is half theta plus B is 2.5 theta. 2.5 theta means 2.5 or 5 by 2. 5 by 2 theta. We can simply add this as 0.5, 2.5 is going to be 3. So 3 theta. Now let's do the next one, I. This is going to be sine cos, cos sine, and there's a minus over here. So it's going to be sine A minus B. Remember, in case of sine cos, cos sine, it would be sine sum of the angles. Since there is a minus over here, the minus will also be over here. So this would be sine A minus B. Now the first angle is A plus B. This is the first angle. So we'll consider this to be A. Minus the second angle is B. So ultimately it would be sine A, because plus B and minus B cancels off. So that's how this one is working. The next one is J. So we have cos cos minus sine sine. So that is going to be cos A plus B. That is cos cos minus sine sine. So it would be cos A plus B. Now the first angle A is this one, thrice x plus twice y by 2, plus b is this angle, which is thrice x minus twice y by 2. So this is going to be cos. So if we take 2 as the LCM, this would be thrice x plus 2y plus thrice x minus 2y. So what's going to happen? Twice and twice is going to cancel off, and we have left thrice x is 6x by 2. So 6x by 2 is going to be cos thrice x. Now there is one more sum of angles rule. It is the tan one, which is not very common in the exams. So tan sum of the angles a plus b is going to be tan a plus tan b divided by 1 minus tan first angle tan second angle. If this was minus tan a minus b, then it would be identical to tan a minus tan b, and this one would be plus 1 plus tan a tan b. So that's all. So what we have to do over here is question number D. We can see it is minus over here. So tan something minus tan something and plus that thing. So the first angle 76 is A and the second angle 45 is B. So it would be A minus B. So this would be tan 76 minus 45, which would be tan 31. And question number 8, you can see that this is plus. So 3 theta is A and 2 theta is A, 3 theta is B. So this is going to be plus. This would be tan 2 theta plus 3 theta, which would be tan 5 theta, and that is it. So these questions are similar to the previous questions. So we need the same sum of angle identities. So let's start with A. Sine cos cosine. So that is sine A plus B. So this is A, this is B. So this would be sine A plus B, which is sine 90 degree. Now you need to remember sine 90 degree is 1. Question number B. Cos cos sine sine. So this is A, this is B. So when you have cos cos and sine sine and there's a plus over here, so this is going to be A minus B, cos A minus B. So this would be cos 110 minus 20. So this is going to be cos 90. Cos 90 happens to be 0. Question number C. Sine cos cosine, and we have a plus. So that means sine A plus B. So this is A and this is B. So this is going to be sine 33 plus 27. This is going to be sine 60. Now sine 60 degree, if you remember the rule of the right angle triangle, so this is, if you remember it like this is root 3, this is 1, this is 2, and this is 60 degree. So sine 60 is opposite by hypotenuse root 3 by 2. Question number D. Cos cos minus sine sine, that means cos A plus B, cos cos minus sine sine. So A is pi by 3, B is also pi by 3, so this would be cos A plus B, pi by 8 plus pi by 8. So if we take the same thing added twice, if this was x plus x is twice x, so pi by 8 plus pi by 8 is twice pi by 8, which ultimately turns out to be cos pi by 4. Now remember, you need to convert this in your head to degree. So pi by 4 meaning 45 degree, because we consider pi to be 180 degree. So cos 45 degree from another triangle, which is, if you have an isosceles triangle 1 1, this is square root 2 and this is 45 degree. So cos 45 degrees adjacent by hypotenuse, which is 1 by square root of 2. Question number E. Question number E, we have sine cos minus cosine. So this is A, this is B. So this is sine A minus B. Sine A minus B is sine cos minus cosine. So this would be sine A is 60 minus B is 15. So we can write sine 45 degree. Again, from the same triangle, we can write opposite by hypotenuse 1 by square root of 2. By the way, 1 by square root of 2 can also be rationalized by multiplying upstairs and downstairs with square root of 2. So it is the same as square root of 2 by 2, because square root 2 becomes 2. It doesn't really matter how you write it. Question number F. We have cos cos. No, we have cos 70, then we have a bracket, we have cos 50 minus, then we have tan 70 and sine 50. This is what we have. Let's multiply. If we write cos 70 and cos 50 minus, if we write cos 70, let me, cos 70 times tan 70 times sine 50. So let's see what turns out to be. So cos 70 cos 50 minus cos 70 tan 70, using the identity of sine by cos, can be written as sine 70 by cos 70, and we have over here sine 50. So this cos 70 and this cos 70 cancels off, and we can write cos 70 cos 50 minus sine 70 sine 50, and now it makes sense because cos cos minus sine sine is cos A plus B. So A is 70 and B is 50, so which turns out to be cos 120. Now if you remember what is cos 120, so cos 120, this is the first quadrant and 120 is in the second quadrant. So cos 120 is somewhere around here. So this is 120. Now if this is 120, the basic angle over here is going to be 60 degree. Altogether it is 180 degree. Remember, by the basic angle rule, if something is in the second quadrant, then the angle is 180 minus basic angle. So this is basic angle. Now since it's the second quadrant, cos is going to be negative. So whatever the value we are going to have of the basic angle, so cos 60 degree, it is going to be negative. So ultimately cos 60 degree, we know from this triangle that we just saw over here, cos 60 degrees adjacent by hypotenuse, which is half. So the value would be half, but since it's in the second quadrant, it is going to be negative. If you were to take your calculator and check, cos 120 degree is minus half, and it is the same as negative of cos 60, because cos 60 is half. So since it's in the second quadrant, we write the minus, so it's minus half. Okay, now these sums deal with tan. So I've written the sum of the angle identities for tan. The first one, we have tan something, this is the something theta, plus tan another angle is 1 minus tan some angle, tan some other angle. So it's going to be tan A plus B. So G is going to be tan A, which is 45, plus B, which is 15, which turns out to be tan 60. Now if you remember this right angle triangle, root 3, 1, 2, so 60 degrees is going to be opposite by adjacent, so tan 60 is square root of 3. Now H. Now H, they're giving us a hint, that means tan 45 degrees is 1, meaning instead of 1, think of this as tan 45, and here think of it as tan 45. So it is like tan 45 minus tan 15, 1 plus tan 45 tan 15. It is like minus, meaning tan A minus tan B divided by 1 plus tan A tan B. So it is going to be tan A minus B. So tan A is 45 minus B is 15. So this is going to be tan 30 degree. Now again, from this right angle triangle, this is 60 and this is 30. So tan 30 degree is going to be opposite by adjacent, 1 by square root of 3. You can either write it as 1 by square root of 3, or you can rationalize by multiplying both sides, upstairs and downstairs, with square root of 3. 1 into square root of 3 is square root of 3. Square root of 3 into square root of 3 is 3. It can either be 1 by square root of 3 or square root of 3 by 3. The next one is I. So you have tan something minus tan A minus tan B, 1 plus tan A tan B. So minus means difference of the angle, so tan A minus B. So this would be tan 7 pi by 12 minus pi by 3. So that would be the idea. So tan, so if you take the LCM is going to be 12, 3 fours are 12, 3 ones are 3. So 12 is going to be LCM. So 7 pi minus 4 pi. So that is going to be tan 3 pi by 12, which is pi by 4. Pi means 180 degree. So pi by 4 is 45 degrees. If you use the other triangle, This is 1, this is 1. Remember, this is square root of 2. If this is 45 degree, it is going to be 1 by 1. So tan pi by 4 is 1. The final one is not a tan question. The final one is a sine cos question. So this is number J. We do number J over here. So they have given us some sort of a hint. They are telling us, look at question number E. Well, question number E was, if we scroll up, so this is question number E, sine 60. So here what they're saying, instead of root 3, we have to write sine 60. So sine 60, but sine 60 is root 3 by 2. So since this is root 3, we have to cancel the 2 over here. So we have to write 2 sine 60, so that we have square root of 3. Because in this question they are giving us a hint. We have to lift sine 60 over here, and instead of square root of 3, we have to write 2 sine 60, because sine 60 is root 3 by 2. So next, it has to be cos 60. So here it has to be cos 60. So cos 60, but cos 60 is half. Here we have 1, so we have to write it as 2 cos 60, because 2 into half is 1. So that's the hint. They are saying, instead of root 3, write sine 60 into 2, which is root 3. Instead of 1, write cos 60 into 2, which is 1. So that means we can write the question all over again. 2 sine 60 cos 15 minus 2 cos 60 sine 15. If we take 2 common, it becomes sine cos minus cosine. Remember, sine cos minus cosine is sine A minus B. So this is going to be sine A is 60 minus B is 15. So this is going to be 2 sine 45. And if you remember this right angle triangle over here, sine 45 is opposite by hypotenuse. So this is going to be 2 into 1 by square root of 2, or 2 by square root of 2. Now if you rationalize this and multiply square root upstairs and downstairs, it can also be written as 2 square root of 2 divided by square root of 2. Square root of 2 is 2, and we can write it as square root of 2.